So far, we've studied trig functions and we have their basic definitions down. That's great. However, we can actually make use of some additional properties to get some surprising results. The first property, or actually it's a proposition that I claim, and then we will go through and prove in a very light manner, is that every trigonometric function is either even or odd. And if you don't remember what even or odd means, it has to do with, strictly speaking, it's an algebraic definition, where if we look at the opposite of the input, if we substitute that into the function and we get the original function back, then we say it's an even function. It'll also have symmetry over the y-axis. So the classic example is something like y equals x squared, where we would say that this thing is an even function because it has symmetry over the y-axis. The other case would be if the function is odd. So in that case, if we substitute in the opposite of x, again, opposite of x, we would get out the original function, but with all the signs changed. So equivalently, it would be the same as putting a negative out in front of the function. Okay, and so an example of this would be something like y equals x cubed. And when we think about the graph of that thing, so it looks something like this. In this case, for odd functions, what we do is we kind of fix the origin, and then if we rotate this thing 180 degrees about the origin, we get the same thing. That's called rotational symmetry. Okay, so great. That's a brief reminder of what even and odd mean, but we are still claiming that every trigonometric function is either even or odd. Also, P.S., if a function is neither even nor odd, we say it's neither even nor odd. Spoiler. But let's take a look. Okay, let's investigate this a little bit further. So we're going to think about theta being an acute angle in standard position on the unit circle. Okay, so I need a picture, and it's a sketch later on in the instructions. So we're going to do that. Let's get a better line going. Okay, so here is my wonderful circle. Hey, that isn't too bad. We are going to draw theta. So I'm going to say, okay, here's my initial side, and then I'm saying that theta is this, and then it says sketch theta minus theta. Okay, so then I would go by the same angle measure, just in a clockwise fashion. Okay, so there's negative theta. Okay, and then it's saying, well, what is sine of minus theta? And the idea is that we're looking for one of these two things to pop out. Okay, so is it the original function or is it the opposite? Okay, and to do this, I need to do just a little bit more investigation. Remember that at the tip of this terminal side, where the terminal side of the angle hits the unit circle, we might have the point x, y. And then for minus theta, the kind of the position, since we're keeping the same angle, we're just changing direction of rotation. This point down here, we're at the tip of minus theta, and where that terminal side intersects the unit circle, that would be the same x value, but the opposite y value. Okay, so then if we look at sine of minus theta, that would be using our trig ratios, minus y over 1, which is minus y, right? Now, if I compare that to just sine of normal theta, right? Sine of theta using this picture now, that would be y over 1, which is positive y. Okay, so in other words, if I compare sine of minus theta to theta, right, this would be negative of what sine of theta was, because sine of theta, right, was the same as y. Okay, so because I have this happening, I have the minus theta, the minus on the theta comes out in front effectively, right? So this comes out in front. This would mean that sine is an odd function. Okay, so sine is odd. Let's see what happens to cosine. Cosine of minus theta, right? Cosine of minus theta, so I'm down here. Cosine is x over 1, which is just x. And if I compare that to cosine of just theta, right? Cosine of just theta would be x over 1, which is exactly the same here as what cosine of cosine of minus theta was. Okay, so since these are the same, this is going to be even, right? So another way that I remember this property is that the minus sign that we had on cosine just disappears, right? It disappears. It's just a positive in front. Okay, so we've done sine, cosine, and I'll leave it to you to pause the video in a moment here, and I'm curious about tangent. We did not do it formally, but I want you to try it based on what we've done so far. So look at tangent of minus theta, pause the video, and see if you can determine whether that's even or odd. Tangent ends up being odd. Okay, and so now I didn't discuss the reciprocal functions, the cofunctions, only because they're going to have the same parity. So they're like, so if sine is even, or sorry, if sine is odd, then cosecant is going to be odd. So the parity doesn't change the even or oddness. Okay, so you can fill that in. Now, oh, and we did tangent, so we're speeding right along. Okay, examples. Okay, how in the world do we even use this? They're great facts to know, but why is this important? Well, it allows us to maybe do some calculations that we could have done before, but it maybe speeds them up just a little bit. For example, with cosine of negative 7 pi over 4, since cosine is even, the negative inside on the angle deletes because of the evenness. So it's just cosine of 7 pi over 4. And now I go to the unit circle and pick out the x value, which is square root of 2 over 2, and then all over 1. So I just get square root of 2 over 2. Okay, and so this property allows me to translate from something that is not easily found on the unit circle to something that is. Okay. In the same vein, sine of negative 5 pi over 3, since sine is odd, this negative is going to come out in front. So this is the same as negative of sine of 5 pi over 3. Okay, and then evaluating this using the unit circle, I'd have negative sine of 5 pi over 3 is going to be negative, nope, but it's going to be negative square root of 3 over 2, all over 1. So just negative square root of 3 over 2. And simplifying, negative of a negative is positive, so square root of 3 over 2. Okay. And then lastly, this last example says if tangent is, a tangent of t is 3 over 4, then what's the value of tangent of negative t? Well, let's look at tangent of negative t, right? We know tangent is odd, right? So then this is the same as negative of tangent of t. And it says up top that tangent of t is 3/4. So I just have tangent of negative t is negative 3/4, and I'm done. Okay, so the upshot of using even or oddness is it can really speed calculations up and can either delete a negative or move the negative in front depending on whether it's even or odd.